In experiment 6, you will figure out the type and concentration of the color used in green M&Ms. You will do this by using a number of techniques you've learned throughout the semester, including making a calibration curve, pipetting, and spectrophotometry. The food coloring agents you will use have some very complex molecular structures. You can see that all of them are highly conjugated, that is, they have many alternating single and double bonds which enables them to absorb visible light. Very slight changes in the molecular structure can have significant impacts on the color. For example, replacing a hydrogen in the structure of brilliant blue with an alcohol turns the dye from blue to green. Similarly, slight changes in R1 and R2 will change the color of sunset yellow to red. In this experiment, you are faced with a conundrum. How do you figure out the concentration of your dye in a sample with unknown composition? To achieve this, you will be using a technique called standard addition. This is a technique employed when you have a complicated mixture of substances but are only interested in the concentration of one component. Making a calibration curve is difficult because you don't know what to use for your calibration curve. Instead, we will use standard addition. This method involves adding a series of known concentrations of the compound we are interested in to your sample. You will then measure the resulting absorbance, plot it against the concentration of added standard, and add a trend line to your data. We can now extrapolate the trend line backwards until it intercepts the x-axis. The absolute value of the x-intercept is the concentration of our unknown. We can also figure out the intercept mathematically. To find the x-intercept, you need to figure out the equation of your trend line, set y equal to 0, and then rearrange it to solve for x. We can now figure out that the concentration of the unknown in this example was 0.1 molar. Each group will be allocated a single dye and figure out an absorption spectrum for this dye. You will then combine your results with other groups to figure out which dye is in the M&Ms and what its concentration is. Once you know which dye to use for your standard addition, add 3 green M&Ms to a test tube and then add 0.1 molar acetic acid to carefully dissolve the dye. Take care to dissolve all dye from the M&M but none of the chocolate underneath. Your solution must be clear to obtain an accurate UV-vis reading. If you leave your M&Ms in the acetic acid for too long, your solution will become cloudy and you have to start again. Record the absorption spectrum of your solution, remembering to blank the instrument with 0.1 molar acetic acid. You will then prepare your standard solutions of the dyes you have found in your M&M. Take the stock solution and dilute it by 1/2, 1/4 and 1/8. You can speed this process up by using a technique called serial dilution. For example, to go from 1/2 the stock concentration to 1/4, simply add 12.5 milliliters of the solution at 1/2 concentration to a new 25 milliliter flask and use acetic acid to top it up to the line. Remember to use a funnel to avoid spilling your solution. Once you have made your standards, you need to prepare 4 cuvettes, each containing 2 milliliters of your unknown and 2 milliliters of a single standard. Measure the absorbance and plot the resulting data as outlined at the beginning of this video to determine the dye concentration in your unknown sample.